In order to find out the number of epochs that you should use when you estimate your model, we're going to be using the history of the estimation. So we're going to define a variable history, which is model fit. Yeah, so up till now everything is the same as above. So we specified the model, it's exactly the same model as above using keras sequential. We compiled it and now we're going to fit it. The way we fit it is we first give the images, then we specify the labels. We're also going to specify the number of epochs. So now we specified at 20, but we're going to, because we're looking at the history, we're actually going to get the results that you would get if you specify 1 epoch, 2, 3, 10, as we did before, all the way up to 20. You can also specify the batch size, which is the number of samples that is being used to update the model. So let's say that's equal to 512. And we specify what the validation data is. Validation data, which in our case consists of test images and test labels. So this is our model, and we fit it now, taking into account all the different epoch choices we could have chosen. And this will allow us to actually figure out what the right number of epochs is going to be. So we're going to run this, and while it's running we're going to be continuing. So we're going to be plotting the loss, which comes from history dot. So the history variable that we specified, so let's get rid of this. So here we defined history as model fit, and this history variable actually has a history attribute where we're interested in loss. So this is the loss on the train data, but we also want to know what the loss is on the validation, or in our case the test data. Oops. So this is history dot history, the validation loss, oops, this is not correct, of course, it should be equal. Then to plot, we're gonna say what the number of epochs is. So when we plot, it's nicer to start with 1. So we consider the length of this array loss. But of course, since we're starting to count at 1, not at 0, we have to add 1 here. And then we can use plt plot epochs. We're going to specify that we want to plot loss, so that's the loss that we get out of the history, as specified here. We're going to use this notation here, so actually the O here means that we're plotting points, not a line, so that's actually the same as, or very similar to scatter, than if I would have used the plt scatter. And we're going to give it a label, and the label is going to be training loss. So that's the first thing that we're going to plot. The second one is plt plot. Again, it's epochs. Then we plot the validation loss. So that's the second variable we defined above. And the label is, oops, label is validation loss. So PLT x label is going to be epochs. PLT y label is going to be the loss, and then it would be useful to have the legend as well, of course. So let's see what that looks like. So what we see here is that the training loss keeps on falling as we increase the number of epochs. But when you look at the test data, our validation loss, it actually doesn't keep on falling. Yeah? So from, let's say, 10 onwards, it's rather flat. So the improvement that we're getting by increasing the number of epochs beyond 10 is actually due to overfitting. Yeah, so the model starts to pick up properties that are particular to the training set, and which actually do not generalize to the validation set. So from looking at this graph, it's clear that the number of epochs should actually not be bigger than 10. Yeah, which is the point where this blue line sort of starts to level off. Yeah, so if you don't see a clear pattern yet, if you specify 20 epochs here, then simply increase it to 50 or whatever, and make sure that you see the point where the loss on the validation data starts to level off. And that's the number of epochs that you would like to specify in your model estimation, yeah, when you estimate the model in its final form. You can do the same, and actually in the notebook we do the same for the accuracy that we specified. So here we only plot the loss, but you can do the same for accuracy, and you can follow the notebook to do that.